In today's lecture, we are going to learn about lumped element matching. First of all, what do you mean by a matching network? Matching network means that type of a network in which we get the value of ZL, that is load impedance, equal to characteristic impedance, total matched impedance. Total matched impedance means zero reflections and VSWR value becomes equal to 1. So in this case of lumped element matching, we say that your final circuit will look in terms of inductance and capacitances. Each point which will be plotting will always have two sets of solution. In this lecture, you will be learning the steps of designing a lumped element matching. One problem will be solved by me, and the second problem will be given for you all for practice. All the best, and let's learn the lumped element matching together. Today's lecture, we are going to actually start with lumped element matching. To understand about the lumped element matching, we are supposed to know certain basics about the solid circles and the dotted circles. The solid circle in a Smith chart is always your unity gain circle. Unity gain circle over here, I'm highlighting it with red. You can just have a view on it. If you remember last time in Smith chart, we have already gone through that circle in which we had plotted 1 plus J1. One circle was the resistance circle was highlighted. So you can see over here, this circle which we are going is called as your unity gain circle. So this is a solid line. Can you all see it? I hope you're able to see this unity gain circle over here, right? It's a unity gain circle. Whereas exactly same, I use some other color, exactly same, passing through this unity gain circle, we have another circle. Can you see over here on the left hand side? I'm trying to do it by blue color. It's a dotted circle. Can you all observe this? It's a dotted circle. It's a dotted circle. So we have a unity gain circle, that is a unit resistance circle, and we also have a unity conductance circle. So anything which is drawn over here, if you are passing through the solid circle, which is marked over in red color, will be always drawn with a series connection. Whereas anything which is drawn on the dotted circle will be always drawn with a shunt connection. These are the first two rules for drawing for doing any lumped element matching. Suppose you are moving in the upsides. Now that I'm using by some other color, maybe a yellow. Now what happens? Suppose I'm trying to draw a lumped element matching, and by drawing element matching, how do I start? Suppose I'm trying to go up. Now when I'm saying going up means I'm starting from this value. Can you see it is 1 here? So when you are going this side, it is 1.2. I hope you are able to see it. It's 1.2 here. This is 1.4. This is 1.6. So suppose I am going up over here. Is some point which can move exactly. Yeah, I think this is 1.4. So this 1.4, you can see over here, it's a dotted line. Can you all see this? I'm going along the dotted line. Yes, I'm supposed to move up. So when I'm moving up over here, when I'm moving up, this movement of going up, we always represent it as an inductor. So how will you plot it? You will be plotting, since you moved along the dotted line, since you moved along the dotted circle and you were moving up, you will be drawing a shunt inductor. A shunt inductor. Let us take some other example. Suppose we are going to use, suppose you're going down now. Now this is 1.4. I'm going down along the circle. I'm drawing a green color. Can you all see this? I'm going down, downward movement. And again, I'm going this time using a dotted line. So what will happen, since I'm going down, I'll be plotting a capacitor, but this is along the dotted circle. It will be a shunt capacitor. Shunt capacitor. Are we clear? Are we clear with this? Fine. So we are going up and down. Anytime we go up, it has to be an inductor. Anytime we go down, it has to be a capacitor. Now let us see what happens when you move along the solid circles. Now you can see the solid circles are mostly towards this side. Towards this side. You can see over here. Now over here, how do we go? Suppose I'm taking any point, any one point if you want. Suppose I'm taking this point, this is 1. So this is 0.8, 0.7, 0.6 maybe. You can take it over here. Yeah, this point we can take 0.6. Suppose we are going up. We are going up. Can you all see this? I'm going up along the solid circle. So what will you plot? If I'm not wrong, if you're able to understand, I went along the solid circle up. I'm going up. It has to be an inductor. Since it's a solid circle, it will be a series inductor. Same thing, I'm using some other color. I'm going this time down. Can you all see it? I'm going down. Since I'm going down, this time it is going to be a capacitor. Since I'm going along the solid circle, it will be a series capacitor. Series capacitor. I hope you are clear with these terms now. Now let us understand that how are we going to learn the values. The value formation is done in this way. Suppose we are going along the solid circle. Solid circle means actually we are having the value which is given on the Smith chart. For example, we all know how do we plot an impedance? Impedance is always taken the inner half of the Smith chart. Inner half of the Smith chart, please look at this yellow color which I'm going. I am at my 0th point. What is the 0 point? This is resistance equal to 0. Can you all see this? This is my short circuit point. A short circuit point. I think I'll use red color. It's a short circuit point. Here you have the 0 impedance. Then you slowly start going up. Am I right? When you go up, it becomes 0.1. Can you see that? Then it becomes 0.2. Then it comes up 0.3. Then it comes here 0.4, 0.5. Do you remember we used to mark this as impedance arcs? We used to plot it as impedance arc. So somewhere over here you had got 1. Am I clear? Am I clear? We are done last time. So we got an impedance of 1 here. So this thing which you are seeing directly, clearly this is a solid arc. This solid arc is actually nothing but is called as these solid arcs. We are going to take the reading for any time whenever a solid arc is cutting. Meaning what we want to say is that you can see over here this is 1. Then we have 1.2. Can you all see it everybody? 1.2. Then we have over here 1.4. Then we have over here 1.6. I hope it is clear. 1.8. You have 2. Meaning the reading of impedances is going on increasing when we are moving from this side in the clockwise direction. Can you all see it? It's moving in the clockwise direction and my impedance value is slowly increasing. Now this is true for all your, it is true for all your solid arcs. It is true for all your solid arcs. Now if somebody comes and tells you that what will be the value for a dotted arc, please note for each point there is a solid arc as well as a dotted arc. Now how do I check for a dotted arc? Very simple. It is very simple. Same way, maybe I'll use some other color, maybe a purple. Yeah, the purple color is visible. So this purple color, so how do? We'll go in the same way. But remember, when you're taking a solid arc, you had moved as shown in red color in clockwise direction from left to right. Now when you're taking for a dotted impedance or dotted arcs, which is susceptance, you will always move from opposite direction. Meaning we will be moving from here. We will be moving from here. Because both cannot be same. I hope you know both are inverse to each other. So your readings will be starting somewhat from here. You will be starting actually as 0 here. This will be your 0.1. This will be your 0.2. This will be your 0.3. This will be your 0.4. Can you all see it? It's dotted. It's dotted. Can you all see it? It's dotted. So a same line can be used as an arc of solid as well as dotted. So when you're taking the reading of a dotted arc, the reading will go on increasing from opposite direction. It will move in anti-clockwise direction, which I have shown it by my purple color over here. When you're taking it for a solid arc of impedances, the reading will go in clockwise direction from the left hand side. Now how do you note the readings? Please note in a normal Smith chart, for solid arcs, the impedances are always positive in the upper half, whereas the impedances are negative, capacitive in the lower half. It is capacitive in the lower half. Now when you are taking dotted, it will be upwards, it will be negative. I am talking about the purple one. Here upper half will be always negative. whereas the lower half will be always positive. So in short, whenever it is solid arcs, it is inductance in the upper half, capacitance in the lower half. So plus J upsides, minus J lower side. Whenever it is susceptance, I mean dotted arcs, it is minus J in the upper half and positive plus J in the lower half. I hope this basics is clear for you all. Then only we can start with lumped element matching. Thank you. In today's design of lumped element matching, we are going to actually match ZL is equal to 10 plus J 10 ohm to a 50 ohm transmission line. Step number 1, we normalize the impedance. So ZL equal to 10 plus J 10 upon 50. On solving you get 0.2 plus J 0.2. So we are supposed to plot the impedance. For plotting the impedance, first along the resistance line, we plot 0.2. So that 0.2 is already plotted for you. That 0.2 will be plotted up. And impedance was given plus J 0.2. So that impedance also is plotted over here. I hope you understand. This is the impedance of plus J 0.2. This impedance has been marked. Can you all see this? Impedance. So this impedance is marked and this is the point which we got. So this point is our impedance plotted, that is ZL, which is 0.2 plus J 0.2. Now how do we start with the lumped element matching? In lumped element matching, we have to find out along which circle we are supposed to move, one, and secondly, till where we are supposed to move. So in this entire lumped element matching, we are very clear that we are not on the unity gain circle. Meaning, unity gain circle lies on the right hand side. Am I clear? This side, blue one I'm drawing. You can see over here. I'm assuming you all have heard my lecture of earlier of plotting unity gain circles and all. Okay. So this blue one, this is my unity gain circle. So this is on the right hand side. So we are not on the unity gain circle side. We are actually on the other end. We are actually on the dotted circle side. So when we are on the dotted circle side, we are supposed to go on moving till we reach that side, till we reach that point. So how will we move? I'm using yellow color. So this yellow color from this point ZL, this point is ZL, I'm going to move till it reaches my circle. So see this point, I'm slowly going to move up, 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 up and reach till this point. Why did I stop there is because I'm just supposed to find out the point till where I'm supposed to move that point to. Meaning this circle, I'm using some other color. You can see this is my unity. Can you all see this? This circle, dotted circle. I'm highlighting it with purple color. Can you all see this? Normally we do not highlight the dotted circle. It is just for your reference I am doing it. Normally we do not highlight it. This is a dotted circle. So we are supposed to move the point to either to the dotted circle or to the solid circle. Since we are in dotted circle side, we will be on the left hand side. So as a result, as shown by the yellow color, we are supposed to move the point ZL to the dotted circle point. So when we are moving to the dotted circle point, what will be the values? Now how do we go about it? The arrow I am drawing is in this way, meaning you have gone from this ZL point, you have touched this point and you are at the dotted arc point. So how do I measure the value? You can see. Now looking at this arrow, how do we find out? You have moved along the solid circle. In what movement does this yellow color show? You have moved up. So what will you make? You will always make an inductor. Along which circle did you move? You moved along the solid circle in the upward direction. Solid circle, series connection. Upward direction, inductor. The first diagram which you are going to make is going to be about an inductor. It's going to be a series inductor. Am I clear? I repeat. We moved from the ZL point. We moved upwards to reach this dotted circle. Along which circle did you move? Solid circle. Solid circle up movement. Solid circle means series connection. Upward movement means inductance. The first circuit which you are going to draw is a series inductor. Now to find the value of that inductor, how do we go? we follow the arrow position. It is always destination. Which is your destination? This one, this point. This, you have reached here. So this is your destination. Destination minus source. So destination over here, you have to tell me, since you moved along the solid circle, you will tell me the value at which this particular line has been cut. So can I say this line has been cut along? Let me help you all with this. It is cut along. Can you all see this? I'm going up. This is a solid arc. So can I say the value of this is plus? I'm just writing it up. It is plus j. It is plus j 0.4. Plus j 0.4. Am I clear? Plus j 0.4. How did I find? You moved along the solid circle and you have intersected that dotted line. Since you moved along the solid circle, it's going to be, you have to find about the solid arc, it is high. Now that is the destination point. Now the question that comes is, what is your source? You started from ZL point and this ZL point is actually marked here. Can you all see this, everybody? I'm just marking, I'm again highlighting it. It is nothing but, what is your destination, your source? Source is nothing but plus j 0.2 plus j 0.2. The formula says destination minus source. So it is plus j 0.4 minus j 0.2. Answer you will get plus j 0.2. The answer is plus j 0.2. Am I clear? Plus j 0.2. So after finding this plus j 0.2, I want the value for inductance, capital L. You are telling me the answer in terms of omega L. I'm not interested in omega L. Omega L is equal to, always the formula says, omega L is equal to, whatever value you got the answer as 0.2, right? So omega L is equal to 0.2 into, if it is a series connection, it is always multiplied by Z0. But if it is a shunt connection, you will always take it as 1 upon Z0. So the final formula, since it is a series inductor, your formula will come out to be as omega L is equal to 0.2 into Z0. On solving, you will get the answer of capital L as 1.59 into 10 to the power minus 9 Henry, 1.59 nano Henry. Now, we will be moving on to the solution 2. So for each point, there are two ways by which you can move towards your dotted circle or your solid circle. As you remember, in solution 1, we were in the dotted circle part. This time also we are continuing with the same circle. Last time we had moved towards upward direction, but this time we will be moving towards the lower direction. If you remember, this was the ZS point. This was the, ZL point, 0.2 plus j 0.2. And now we are going to move downward. Now when we are moving downwards, if you remember, when we are moving towards downwards, it is always represented by a capacitor. And since we are moving along the solid circle, can you all see this? Solid circle, it's a solid circle, not a dotted one. I'm stopping here. Why do I stop here is because this circle represents this circle which we are saying, I'm using some other color. This circle is a dotted circle. A dotted circle. I'm just highlighting this circle so that it becomes easier for you all. This is a dotted circle and this dotted circle has to move towards the impedance matching point. So while it is moving towards impedance matching point, as you can see, I have stopped the movement. I have stopped the movement of this red color, you can say red color circle, red color point over here. The moment it touches here, we are supposed to find the value. So what type of circuit are you going to draw? This is in the downward movement. Yes. This is in the downward movement. So this is going to be a capacitor. It's going to be along the solid circle. Hence it is going to be a series capacitor. It's a series capacitor which you have drawn. The value of this capacitor, how will you find? Since it is moving along the solid circle line, this curve, solid circle curve, over here you have to find a solid curve. Now the solid curve for this is, as you can all see, can you all see over here? I'm just highlighting the red one over here. This is the solid curve for this solid circle which you have moved, and this value I will be writing it as, what will we write? Will it be plus or minus? It is a normal Smith chart and it is in a downer part. It has to be minus j 0.4. Can you all see it? It is 0.4. Alright, now how do you find the value of the capacitor? That is going to be destination minus source. What is it? Destination minus source. So which is your destination? Your arrow is moving from up to down. So this is your destination. This is your destination and your source is this. What is this destination value? It is minus j.4. What is your source value? Your source value, if you remember, was your solid arc. That value was plus j.2. So when you solve it, it becomes destination minus source minus j.4 minus j.2. Answer becomes minus j.6. The value of this capacitor, being a series capacitor, it is 1 upon omega c. Please note, series capacitor value is 1 upon omega c is equal to minus j.6, that is minus 0.6 into, since it is series, it will be multiplied with the characteristic impedance Z0. On solving, you will get the value of capacitor as 5.3 picofarad. I hope it is clear. The circuit for this will be nothing but a series capacitor. Now in last lecture, we have already seen that we had marked the solution to circuit diagram in which we have stopped at series capacitor. Now we need to find out what will be the next part of it. I'll just redraw that part of series capacitor for you all so it becomes easier for you. So I told you that we'll be moving along the solid circle. We are moving along the solid circle. It's going down, 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 down. Until where do I reach it? So that point, what did I tell you? That you have to stop where it reaches your dotted circle. For me, dotted circle is this point 1 where I'm supposed to reach. Now I'm going to go up. Why am I going up? Because I'm supposed to reach always my unity gain circle. So for my unity gain circle, what do? I take a blue line and I'm starting from here. You can all see it's starting from this blue and I'm just going up. Can you all see this? I'm going up. Since I'm going up, no doubt now it has to be an inductor. I'm moving along the dotted circle. It's going to be parallel inductor or a shunt inductor. What will be the value of this inductor? The value of this inductor will be again the same way. We are going to take destination minus source. I repeat, it's going to be destination minus source. So your destination is over here. I hope you understand. This is your source. We have moved along your dotted circle. So for the dotted circle, what will be the susceptance value? It is dotted. Please note, not the normal Smith chart. It's a dotted. So over here, you can see I'm just highlighting this point blue color. It comes over here. Can I say that it was J2? It is coming J2. Now this J2 value, should I take plus or minus? Remember, it is a dotted, that is dotted arc. So it will be always plus J2. The lower half will be plus J2. When it is plus J2, the formula says it is going to be destination minus source. Destination, if you remember, I had told last time also, this destination is going to be real value is 1 and imaginary 0. So the formula says 0 minus of J2. So it will become 0 minus of J2 is J minus J2. Now that is the value of your inductor. This is a parallel inductor. So the omega L, 1 upon omega L is equal to minus J2 into, since it is parallel, it is 1 upon Z0. So your formula becomes 1 upon omega L is equal to J2 into 0.02. That is, I'm saying 50 ohm was your Z0. So 1 upon Z0 becomes 0.02. On solving, the value of inductor L becomes 3.98 nanohenry. For solution 2, your circuit is going to have a combination of series capacitor and a shunt inductor. That's how solution 2 will look like. So in total, the total circuit diagram for this lumped element matching, which comes in paper for 10 marks, will be first solution 1 and solution 2, which will be shown in the next slide. Thank you.